Welcome to section 9.4. In section 9.3, we had to work out, using the value of mean and the standard deviation, to work out the probability. In this section, we will learn to work backwards. We will be given a value of probability, and we will be asked to work out either the mean or the standard deviation, or in some cases both. So let's have a look at an example. In example 5, we're given that x is normally distributed with an unknown value of mean mu and the standard deviation, which is equal to 3. The probability of x being bigger than 20 is equal to 0.2, and from this we need to work out the value of mu. The first thing, as always, is to standardize the probability. So probability of x being bigger than, probability of z being bigger than 20 minus mu over 3 is equal to 0.2. Remember, the probability does not change. Now, if we sketch the graph, it's the z bigger than a certain number, so the probability is going to be from the right, and the total probability is only equal to 0.2. That means this value is a positive number, which means in turn that this is a probability of z being bigger than a positive form. It's bigger than positive form, but fortunately the probability is a nice percentage, so we can use the percentage table. So 0.2's corresponding z value is 0.8416. So 0.8416 is equal to 20 minus mu over 3. This is the z value. From this, it's easy to work out mu. 3 times 0.8416 is equal to 20 minus mu, and so mu is equal to 20 plus, take away 3 times 0.8416, let's use the calculator. 20 minus 3 times 0.8416, this is 17.5 to 3 significant figures. 17.5 to 3 significant figures. Remember, it's good to round your answers to 3 significant figures, but whenever rounding, you must say that you've rounded to what. Okay, next example is you're given that x is normally distributed with a mean 50, and you need to work out the standard deviation. You have, of course, given that you will also be given a probability fact. So in this case, probability of x being less than 46 is equal to 0.2119. Again, first thing is always to standardize. 46 minus 50 over sigma is equal to 0.2119. This means that, well, let's first sketch the graph. Is z being less than a certain number, so the error is going to come from the left, but the probability is only 20%, so let's just say up to here. So the z value, this, is a negative number. And actually, we can see that if we work this out. So it's minus 4 over sigma, and sigma is always a positive number. It's a standard deviation. So we'll have to use the symmetry to reflect. This will become minus z. That means probability of z being bigger than 4 over sigma is equal to 0.2119. Now this is in a bigger than positive form, so we use the 1 minus method. Probability of z being less than 4 over sigma is equal to 0.2119. This means that probability of z being less than 4 over sigma is equal to 1 minus 0.2119, which is equal to 0.8, sorry, 0.7881. We can now look this up on the probability table, the big probability table, 0.7881. And we find that the corresponding z value is 0.8. So 0.8 is equal to 4 over sigma, which means that sigma is equal to 4 over 0.8. And this is equal to 5. Last one. We're given a normal distribution, x, but we have two unknowns this time, mu and sigma. But to help us to solve this problem, we are given two facts on probability. Now, there is a typo in your book which you should correct. Instead of 0.05, it should say 0.025. To solve this, you will need to get two equations which includes mu and sigma, and then solve a simultaneous equations using those two equations. Alright, let's see what we mean by that. We've got two probability facts. Let's standardize them. Z being bigger than 35 minus mu over sigma is equal to 0.025, and we're also given that probability of z being less than 15 minus mu over sigma is equal to 0.1469. Let's do one at a time. Sketching this, we have z being bigger than a certain number, so the area is going to come from the right, and the area is only 0.0025, so let's just stop here. So the z value is going to be a positive number, so it's in a bigger than positive form, and it's in a nice percentage. This is a 2.5%, but it's going to be in the percentage table form. So let's look up 0.025. 0.025's corresponding z value is 1.96. That means that 1.96 is equal to 35 minus mu over sigma. From this we can conclude that 1.96 sigma is equal to 35 minus mu. Here's the first equation. We've got two unknowns, so we cannot solve sigma and mu straight away with this one equation. Let's see what we can get from this. Let's draw the graph as always. And it's z being less than a certain number, so the area is going to come from the left, and it's only 0.14, so let's just stop here. And so this z value is a negative number, so it's in the less than a negative form. So let's first reflect it using the symmetry. That means probability of z being bigger than 15 minus mu, we have to make it negative, so let's swap this around. So minus of this is equal to this, is equal to 0.1469. The probabilities are the same, remember? So this is in a bigger than positive form now, but this is not a nice percentage that's going to be in the percentage table, so we'll have to change it using the 1 minus method. 1 minus probability of z being less than mu minus 15 over sigma is equal to 0.1469. This means that probability of z being less than mu minus 15 over sigma is equal to 1 minus 0.1469, which is equal to 0.8531. Let's look up 0.8531. This is here, and the corresponding z value is 1.05. So 1.05 is equal to mu minus 15 over sigma, which means 1.05 sigma is equal to mu minus 15. Here's the second equation. So let's use these two equations to solve mu and sigma. You could do substitution by making one of them a subject. It wouldn't be much harder, but whenever you can, I would recommend elimination method. So I can eliminate mu by adding these two equations. So I will get 3.01 lots of sigma is equal to, well, the mu's will cancel, and then it will be 35 minus 15, that's equal to 20. So sigma will be 20 over 3.01, and this is equal to 6.64 to 3 significant figures. 3SF. Now we're not done yet because we haven't found mu. Let's use the second equation. It seems easier. So 1.05 times 6.64 is going to, let's add 15 to that. This is equal to mu. Now this is a way of writing that 6.64 is not exact, but I have decimals left. Now mu then, you can just type this on the calculator, times 1.05 plus 15. This is equal to 30.0 to 3 significant figures. 30.0 to 3 significant figures. So in summary, this was the section where you were given unknown mu or sigma or both, and from a probability you had to work these out backwards. So you had to first work out what the z value was using the table, and then solve the equation. Sometimes you have to solve the simultaneous equations when you have both unknowns, and then you will be able to find mu and sigma. This ends this section of the video. Thank you for watching.